So Typesafe ConductR is something we've been working on at Typesafe for the last 10 months or so. And so obviously I wanted to talk here about our journey, what we found in terms of discoveries and problems, how we've solved some problems in the course of writing this application over the last 10 months. But I needed to show it to you just because hopefully then the rest of it will then therefore make sense. And so feel free to clap as much as you want as we go through this. There will be, it relaxes me. There will be more live coding in this demonstration. In fact, we are going to attempt something that has never been attempted before anywhere. Well, apart from last night when we got it. But apart from that. And I can say that, outside of, I can say that with a reasonable amount of confidence, because the akka team themselves had never done it before. So that's a little thing just to keep you here until the end. Because I know it's the last slot on the last day of the conference, and I get it, right? So you're going to have to stay around now. So who am I? I am an engineer at Typesafe. I've been with Typesafe for a couple of years now. I'm a fully fledged Scala developer. I'm probably the only engineer hired at Typesafe that had never previously used Scala, Akka, or Play on the day that I was hired. So that was quite interesting. I was on the Play team as well. I was even a happy Java developer, right, at that time. And so, I've been certainly on this journey, which I know is a journey for some of you at least that you're embarking on. I've done a lot of open source. I did a lot, I was previously at Spring Source as well. And I did a lot of tooling around JavaScript for Maven. So I do apologize for that. Don't hold that against me. And then now I'm a tech lead on the ConductR project itself. So it's probably useful just to answer this question in your heads if it is indeed a question, and that is, why have we done this? What it is that it is. And so several months ago we got to this situation where we felt that we're doing a reasonable job in terms of educating, and I guess not just educating, but sort of setting the scene. People are tweeting me, how do you turn that off? Thank you, Rod. We felt that we're doing a pretty good job overall with the reactive manifesto and sort of, pushing that forward, to the point where we don't really even own that anymore, right? And that's great, because that's, of course, what we wanted to achieve. And then we felt that we'd arrive pretty quickly at this situation where you guys, start producing these fantastic apps that are reactive, that have these properties of being resilient, that can scale out, in new and interesting ways. And then you go to your ops guys and you go, well, I'd like 10 nodes, please, and they kind of go, okay, because it's kind of not normal to deploy, on tens of nodes. It's more in the sort of handful of nodes, of course, at the moment. So we felt that there would be very shortly a situation where there would need to be some tools in the space that can facilitate the management of that, and hence ConductR. So we know we're not the only people in this space, and indeed, perhaps among you as well, you may have even wrote your own infrastructure to help deal with this a little bit more as well. So that's what it is. It's a reactive application manager that empowers operations to deploy and control distributed systems. And I want to just touch on one word there. So when I started at Typesafe, I was on the Play team. I created SPT Web. I don't know if any of you have actually used that at all, for which I don't apologize, actually. It's my, I think hopefully we got that one right. And Play, of course, is all about developer productivity. And so with ConductR, we wanted to achieve the same goals, or strive for the same goals, that Play, what Play is to developers, we want to make ConductR to operations itself. And over I know I don't look very old, but I've actually been programming for like 30 odd years now, as a job, right? Yeah, it's hard to believe. But these are my principles. Over the last couple of years, I've probably come to realize these principles more than anything. And, as Bart says here, to write less code, but to write higher quality code. And I think I've been on this journey for quite a long time. I remember fourth generation languages 20 odd years ago, and they were sort of promising this a little bit, so I even remember asking a chap, saying, are we going to be out of work, as programmers, robots going to take over? And I was genuinely concerned about this, and of course, it still hasn't happened. Here we are still today. But we're continually trying to do this well, at least I am, to write less code, but to write higher quality code. And of course, I obviously feel that Scala, fits very well into these principles of mine as well. And of course, not just Scala, but the libraries, the toolkits, the frameworks, that we see in our ecosystem. So, distributed systems themselves are not easy. Don't let anyone fool you. They are difficult things. Anything that goes outside of your thread, actually, is kind of an interesting problem to contend with. Now, indeed, with Akka, we strive to contend with that. But when you get to the situation where you have networks involved, in particular, you can guarantee that things are going to fail, right? Things are going to occur out of the order that you expect as well, right? So what we need to do is to develop patterns and principles around how we approach these problems. But there's no silver bullet. You have to make an investment in time in terms of learning, about writing reactive applications themselves. So the cast here is, we see Scala. Obviously, I haven't written all of this in Rust or Haskell or anything like that. I probably wouldn't have a job at Typesafe for very long if I did that. But that's not the only reason, because no one has to be anywhere. I really believe that Scala helps us write high quality code, and not necessarily faster. Sometimes people go out there and say, well, you can be a lot more productive with Scala and stuff like that. It doesn't necessarily mean that you can actually get the code down faster. You could indeed spend more time working out what the expression of this problem itself. But over a period of time, you can certainly be more productive as well. And then we've used Scala pickling for serialization. So Scala pickling has been around for a little while now, and Activator recently has caused us to do a lot more work on Scala pickling as well. And so we've also adopted it on Typesafe ConductR as well, so that we can encode to a binary format in a very type-safe way. The encoding, as I say, is done in a very type-safe way and a highly performant way as well. We use Akka. Should be no surprise, but not just the core of Akka. We're using akka-cluster, we're using akka-streams, we're using akka-http, and we're using this beautiful thing called akka-data-replication. I'm very pleased that Patrick here is in the audience as well. So if anything gets too tricky, I'm just going to feel things over there, I think. But these are great technologies, and I can say with my hand on heart, that writing this distributed app would have been a lot more difficult without these technologies. In fact, I know this because when I was at VMware SpringSource, I did do exactly that, and it was a pure Java-based app, and we wrote a lot of this ourselves. So these technologies have allowed us to move on and solve the problem domain that we're after, rather than getting into writing our own consistent hashing algorithms, for example. And then Play, of course, being on the Play team, I had to get Play in there somehow, right? So we wrote this visualizer, which is what you saw there a little bit earlier. And we wrote that because, well, it's useful, I guess, for doing this sort of thing. But it's actually turned out to be an interesting tool in its own right. And I'll talk about that a little bit more as we go through. So some of the challenges and solutions then that we faced were, they're not necessarily problems that you've got unless you want to write your own conductor and stuff, but one of them was to receive a stream of data and then find a node in our cluster that has the resources available to it, and then continue streaming this file that's being uploaded to that node. So I remember certainly using, I'm pretty sure Spring MVC used to do this, but it wasn't by itself, where if you had a large file being uploaded, and who knows how big a bundle file could actually be itself, then we would write it to disk, and then we would create a new input stream, from that place on disk while we go and, subsequently do something about that. We wanted to avoid that here. So with Conductor, you can hit any node in the cluster, and bearing in mind that you can have hundreds of nodes as well. They're all able to do all the work, all right? And this is an important feature. So we wanted to be able to receive a request at any node, take a little bit of metadata out of that stream, and then with that information be able to make a decision as to, well, not a decision, but to be able to request resources from what we call a resource provider. It's very Mesos-like. We're heavily influenced by Mesos indeed. We're going to become a framework to Mesos as well, for those interested. And so once we locate a node, what we do, so bearing in mind we've got a little bit of the stream here, and we sort of suspend it, and it can take a little while, right, before you get a resource offer or a number of resource offers as that indicate indeed where you can stream this thing to. Then we find that, we communicate with this other node, and we make the stream available from there, and then the remainder, we kind of like plug the streams together. And so nothing's gone to disk yet. Right? It's all being uploaded over the beautiful internet to this node that arrives at, and it's going to then go to some other node where we know we have resources, and then it's written to disk on that other node where we know there is enough file system space, to do that too. Now, to this end, akka-streams, akka-http, and its finite state machines, they're absolutely required. They've been really, really useful to us here. I must say, with FSM, for me, it's one of my favorite parts of Akka. If you've looked at Akka but you've not looked into its FSM, then I would encourage you to go and have a look at it, because it's a magnificent thing. In fact, if you've got any more than 2 states that you transition with inside your actors, then an FSM is something that you should sort of consider. Looking through our code base, I think we've got very few instances of a var in our code base. An FSM allows you to communicate these values through your transitions such that you don't need vars, right? So does akka become and unbecome as well. So that's been terribly useful. Another one was that, once we write to the file system somewhere, then we need to replicate these bundles, we call them bundles, and then scale them, so we want to actually make replicas of these bundles in our cluster itself. And we need to do this in a very coordinated fashion. You don't just want to just write it anywhere. You can't. Again, you have to then look to see what node has got the resources in the cluster, so that you can then ask this replication to then occur. And once that's occurred, replicate again. So we replicate up to 3 times, but we do it in an orderly fashion, because if you do it all at once, then you're going to start flooding the network, of course, as well. So you need to sort of be coordinated. And again, the FSM really helps us coordinate that activity so that we can do it in a very coordinated fashion. And so there's this thing called akka-data-replication. So where that sort of fits in here is, you know how we've been going on for a little while now saying that, you know, having state is a really bad idea. Well, you know what? State exists, and what we've been doing is in fact pushing that problem out under the carpet. You know, we've been persisting it and then sharing it across databases, you know, so your databases themselves retain that state. Data replication sort of brings in-memory state back into vogue. And it's built upon these things called CRDTs, which are convergent replicated data types. I knew I could get something really academic out into this audience as well. And they're a really, really interesting little thing where they have this one unique property, and that is that you can replicate this state across a cluster, and it will always know how to merge. Right? It will always know which one wins. You know, if like two nodes write that same piece of data, then it can always resolve which one is, you know, should win out over the other one itself. And it does that. This is not going to be a presentation on CRDT, so don't worry, you know, but it does that by identifying certain data types that have properties such that they lend themselves to that. Okay, and indeed, you can even define your own replicated types, and they will, you know, and it demands a merge function, and then you decide, you know, what it means in the context of this data type to basically merge. Running akka-cluster-based apps. So, who's done this so far? You know, who's started an akka-cluster-based app up in a cluster, right? All right. Thanks, Akka team. You know, the interesting property of an akka-cluster-based app, and indeed it's not just confined to an akka-cluster-based app, but also to other distributed systems, is that the first one to start needs to know that it's the first one, right? Because it then needs to form a cluster with itself. But subsequent ones need to know about all of the other ones that come before it and effectively use them as what we call seed nodes itself. So what we do in ConductR to support this is we say to that first bundle that starts up, hey, you're the first one. It can determine that it is the first one. And we make the guarantee that no other one will start while we're starting you. All right, so it can form the cluster, and then with subsequent ones that come along, we can actually tell it the IPs and the ports of all of the previous ones, you know, the ones prior to it. So they can become seed nodes, so they don't form their own cluster. What's the point of having lots of clusters? You basically want the one cluster here. And so we've built this notion into ConductR itself, and we think it's quite a distinctive feature. And although, again, we're very focused on Typesafe RP-based applications, this is a feature that could actually lend itself to other use cases, such as starting Cassandra, for example. And so, again, using this finite state machine that's provided by Akka itself, we're able to do this in a very coordinated and orderly sort of fashion. And in fact, akka-data-replication allows us to do this in a very coordinated fashion as well. So before we make a decision, we have to make sure that we have the current, you know, copy of the bundled information. You know, so our view, we have to make sure that our view of the cluster is the consistent view. And so we can ask akka-data-replication to say, give us the read quorum level view of this itself, right? So we know then that the data that's coming back is good enough to make a decision on. So when you saw me earlier scaling a bundle up or down, I initially just said run it, so it's going to give it a scale of 1. Right? And then again, I can, you know, subsequently say, okay, and now I need a scale of 2. And it has to therefore determine, well, I've got 1 running, I need 1 more. But it had better make sure that it's got the most consistent view of this data in order to make that decision. Otherwise, we could probably get 3 itself, right? So you can see the sort of problems then that akka-data-replication allows you to solve. Now, for any of you that have done any form of writing a distributed application so far, then you'll know that logging is a challenge as well, right? So this is a problem that we hit straight away, and I kind of thought we knew we were going to have to tackle this problem, but we didn't really think that it was going to be a 1.0 sort of problem, but in fact it became quite apparent that it was a 1.0 problem that we had to solve. And so what we did was we wrote a syslogging library for the JVM. And if you're familiar with Unix, you certainly would have heard of syslog, of course. And so we actually can write syslog out over TCP. And indeed, we're using akka-streams for this. And what that allows us to do then is to write all of our logs to some logging aggregator, some collector. It could be a cloud-based one, or it could be a local syslog-based one, or something like that. But when writing a distributed app, this is something you really have to think about. You've only got to have more than 2 nodes in your cluster, and then it becomes a really interesting game to find out where that log file belonging to that thing that you're running actually lives on disk. Because you know what? They move around. It moves all over the place. It's a real interesting challenge. So it's not a luxury. Avoiding batching as well. Batching is a very, we like to think about batches, and I remember back to my mainframe days. Anyone else write COBOL here at all? Okay, yeah, knew you would. Yeah, okay, well I certainly wrote COBOL, on an ICL ME29, so you could probably look that up in Wikipedia and you'll see that it has a paper tape feed and all that kind of stuff. But, we used to wear ties and we used to get concerned that we were going to get caught in the feed. We don't have that problem anymore because, well, we don't wear ties for a start. But anyway, batching was very normal in our environment. We used to batch things in COBOL because, A, programs ran fairly slowly for a start, and B, getting machine time was a real problem. And we seem to be kind of a little bit stuck in that age. I'm not suggesting that all batching use cases have now gone, right? They should never batch. But I'll bet you that if you rethink some of your batch jobs, you'll get into a situation, where you'll say, oh, well, actually, you know what? There is some stimulus to this event. There is some event here that I can latch onto, and perhaps I can do this in real time. Okay? So, we had something similar. So, ConductR uses HA proxy. And so, we had this periodic process that would fire given cron, and cron has this 1-minute resolution as its fastest sort of means of firing something off. That's periodic. And so therefore what this thing used to do was poll ConductR to say, hey, have you got any new services? And then we would write that config out to the file system and restart HA proxy. Okay? So that means that you could wait for up to a minute, depending how close you were to a new minute, for your service to become online. That's obviously not desirable, and it's certainly not very reactive. So we were able, given service center events and other technologies as well, to make this a long-running process, and we can subscribe to these events, and then in response to these events coming through, we can then write out this HA proxy sort of config and stuff. So that was our example of where we were kind of doing something periodic, some sort of batch kind of process, and we factored it out of our world. And we always had a plan to do that. There were other reasons why we didn't do it initially. But I would challenge you to think about in a distributed system, your periodic tasks that you feel the need to have. Because the other thing is, it's a little bit of a challenge in a distributed system to have something fire, just on one node. Right, and to do that in a coordinated fashion. It can certainly be achieved, but you've got a bit of a challenge there as well. Okay? So you can be a little more event-driven there. Testing. You are really a problem. Where's security? Testing is a big challenge, right? Who tests? You all test? Of course we all test, right? You know, well, you don't test? Oh, right. You're a customer? All right. We could do some training there. So the thing is, testing becomes a lot harder, right? As if testing's not hard enough, right? Obviously, because only a few of you put your hands up. Well, you know what? Certainly testing things like, you know, data replication across multiple nodes and stuff becomes a lot trickier. One of the things that we found is, and I alluded to this earlier, was that this visualizer, you know, we put together because we thought, oh, this kind of looks cool, you know, we can sort of sell it to management a little bit more and all of that. It became a really amazing testing tool, right? We could see, we got a couple of nodes there, we've got 3 nodes there, and, you know, we want to scale, you know, 2, so we want 2 running and stuff, and we say, oh, you can see just one's running, and we're going, oh, that's interesting, right? And then you can look further into why that problem occurs. Obviously, it's just a bit of a smoke test. It's not going to tell you exactly why, but it certainly beats watching lots of log files sort of scroll through. And of course, the more nodes that you have in your cluster, the more log files there are to watch. You know, so it's no fun watching telling all of these log files coming through. So I certainly would recommend to you, you know, in the course of writing your distributed application, that you have a means somehow of visualizing that and visualizing its behavior. In total, I think that we've spent 5 days in the entire 10 months writing that visualizer. So, you know, it wasn't a massive investment to do so for the return of investment that we got. The other thing that's been really great from a development point of view has been Docker. So we could talk, I think, perhaps contentiously, certainly from my point of view, about Docker in production. Everyone wants to do it. Okay, we can talk about that later. But Docker in development, you know, has some very strong use cases. And indeed, on our team, you know, we use Docker all the time to spin up a few nodes on our machine. In fact, the demo I just did, when I started that demo, actually span up 2 Docker containers, right? So that I could do this demo without pulling in, all relying on the network to, you know, contact some real hardware. So Docker is absolutely your friend during development. It works very well. So at this point then, I want to talk about akka-data-replication. Just a little bit, right? So this is the little demo that I promised earlier, and now you know, I think we need to pray to the higher kinded types, of course, which of course is the demo god, and because things can go horribly wrong, you know, and I know that you're after my blood here. You want to see it all go completely wrong, and it's a very good chance that it will. So what we're going to do is we're going to run ConductR. Hey Jane, we're going to run ConductR outside of a Docker container, so just as a regular process, and then we're going to go into Scala's REPL, and we're going to form a new actor system, and we're going to join that cluster from within the REPL itself. And then we're going to talk with communicate with the replicator, and we're going to get some state, all right? So I just wanted to sort of demonstrate how akka-data-replication is used a little bit. So let's all pray. And you can absolutely clap it if this one works, all right? Because it might not. So let's do this. Where am I? Typesafe ConductR. Okay. So ConductR target. Oh, I'd better just shut down the existing thing. Okay, so that was the cluster that I had before. And I'm going to run universal stage bin visualizer. Oh no, hang on a sec. Sorry, I've just got to see, it's gone wrong already. I think I'm in the wrong window. It's exciting, isn't it? Yeah, I've lost, oh, whew, there it is. Okay, so what this command is going to do is simply, I'm using the native packager here, and I'm going to start ConductR up. I've told it a few ports to sort of go and listen on 9104. Just remember that one, and I've told it to form a cluster with itself. All right, so that's what that does. Okay, and we're going to start up ConductR. Now, here I'm in the ConductR project. Within SBT, and for those of you that don't know, you can type console and you actually go into the REPL, and it will provide you the class path set up by your project. Anyone not know that? Or, it's a really, really useful feature to actually have. Now, I'm just going to type in a couple of boring commands that I'm going to copy and paste here, because you really don't want to see me actually type them in, but I'll explain what they do as well. So I'm going to type that one in first, itself, and this one I'm going to then explain them. So this command here defines some system properties, and all it does is say that this other thing in the cluster is over here, right? So it's on my same machine, but it's running on port 9104. And then this second line down here, all that's saying is that, we're going to become part of the ConductR cluster, and we're going to give ourselves a role such that it's not going to ask us to do something. All right? We kind of have to do those two things. Don't worry too much about why, though. The main thing is that this thing is going to connect. We described how to connect to this other thing. Okay, let's create ourselves an actor system. Right, we've created ourselves an actor system here, and now we're going to create ourselves a cluster with that actor system. And now we are going to create ourselves a replicator with that actor system. And now we're going to import a dispatcher. So dispatcher is an execution context, right? So we need an execution context to perform the next thing itself. Okay. This is where it gets really interesting. So what we're going to do is we're going to query the data replicator, okay, for its current state. So we've got this thing, we have, again, our domain model is a bundle, right? So we have bundle information, and we split that bundle information up into various states depending on the frequency of it getting updated as well. That's kind of something you have to consider for data replication. So let's do that. Let's say val result equals r.replicator. We'll ask it to do a get on bundle info state. That's just a key, right? It's kind of like a key value store, right? You can think of it as a key value store. And we say here read quorum is that we're going to wait for 2 seconds for this data to come through. So by saying read quorum, we're saying that the majority of the cluster thinks is happy with the state of this value itself, right? We can specify other read levels there. We can say that the entire cluster has to agree before we come back. Okay, I'll try. So what I'll do is I'm going to do that. I'll scroll it up, all right, and there you are. Okay, so now we've got that, and I will then print the result of that, and you will see that this feature has been completed, and we have no bundle info state in the system itself. Okay? So now what we can do then is we can go over here. I'm going to do that conduct load command that we had before, and I'm going to load a bundle in there. And so then after this I can do a conduct info, and we should see that go through itself. And the demo gods are not going to work for us. Okay. Well, that was going to be it. So if I actually do this again, we're going to see that we've still got the same state. I'll just try it one more time itself. Isn't it amazing that you can do this like right before the demo and then do the demo and it doesn't actually work? All right, that's not going to work for us. But you can still clap. All right, so I'm just joking. We still nonetheless, what we did there was we still were able to connect to an akka-cluster based app and query the data replicator and then have state conveyed, and it said that it didn't have any state at that point, and then the load command unfortunately got hung up on something for some other reason. Okay, when it comes to akka-data-replication itself, there's we found ourselves building a little bit of infrastructure around it. Now, I certainly don't expect for you to absorb this. When these slides become available, this might be interesting for you to look at, just in terms of being able to manage replicated state a little bit more. And then, from an actor point of view, this is then what it ends up looking like. You extend something we call the replicating actor, that we have bundle info state, and then in our receive we call our, so we're using stackable traits here to manage that replicated state in our actor, and that's kind of how it looks. And that works pretty well for us. The only downside of this that we've seen so far is that when, stackable traits, if you forget to call the super receive, well, then your stackable trait, doesn't sort of get it, okay? But that's the only sort of side effect that the thing that we're not too happy about at this point. So, I was trying to think, over the last 10 months, how could I distill this down into some important points, some important points of learning. And one was, which I haven't really sort of touched on that much, is that you need to convey or read state when making a decision itself, right? You shouldn't make any assumptions about the state that you've got. With data replication, you can certainly subscribe to receiving update events and everything, and that certainly works for some use cases. But if you've got a decision to make at that point, you need to make sure that you've got the latest version of it in memory here as well. And indeed, then when having made that decision, like you're going to scale something up or scale something down, you've got to communicate that to something else. You don't rely on that other thing that could be anywhere having that state already as well, right? You have to communicate that state along with that command, if you like. Another one, and this is not mine, but certainly we found it quite useful, is try and test with 3 or more nodes. Things get really interesting at that point. When you're just testing with 1 node or maybe even 2, it's a little bit boring. Okay, so spice your life up and try at least 3, and then finally visualize your cluster. I don't think I really appreciated the benefits of doing that before we did it. I knew it was a useful sales and management tool to get things over the line and everything like that, but it really became a critical part of the development life cycle in just observing, that things were actually working, should be working the way they are. So that's me. That's all I got for you today. And thank you very much. And I'm sure, I can answer questions if you want, but you can clap first and then answer questions. Thank you. Are there any questions? Or is this just too easy? It must be so easy you've got no questions at all? No? Not one? Yes.
So outside of, I guess, deploying Akka and starting up clusters and using Docker, are you all integrating with like Puppet and Ansible and different things like that? And,
yep.
Okay, how deep does that integration go? Like, does it generate all the Puppet stuff and like handle it for you, or do you just kind of integrate that in with your existing?
Right, so we want to be really customer, thank you for the question. So the question is, do we integrate with other infrastructure provisioning tools such as Ansible, Chef, Puppet, etc. At the moment, we want to be driven by our customers on this. Obviously, there's a lot of choice in that space as to what we could do. So we want our customers to tell us what they are doing. Now, it seems so far that a lot of people are using EC2, and a lot of people are, increased amount of interest around Ansible as well. So, we're certainly going to do something a little more with EC2, I think. There's some really interesting auto-scaling scenarios that we want to explore, both within the cluster itself, but then also being able to have these events cause scaling outside of that at the infrastructure level by integrating, with EC2 and other things. One thing we're definitely doing next quarter is also, of course, integrating with Mesos by making ConductR a Mesos framework. So right from the very beginning, we adopted the Mesos architecture of making a request for resources and processing resource offers, and so we're in a really great position to take advantage of that. Now, when we do, that means we leverage all the benefits of that world, everything that's happening in that space as well. So, if people are using a lot of Chef and Puppet and Ansible in that space, then we're going to gain that benefit, I would say, immediately as well. But again, the major point is that we want to be driven by our customers on this. But I'd be interested, if you've got some strong thoughts on that, then please let me know. Yeah. Yes, sir. Hi.
So, what software did you use for visualization of the cluster?
Oh, okay.
And, are there any other best practices while developing a distributed application, visualize or start with a certain architecture that's easy to handle or whatever?
Okay, yeah, all right. So the software we use, the stack there, it's a Play app, of course. That was how I got Play into there, right? And so using SBT Web and JavaScript, and the library is D3. Everyone uses D3.js, and so I've used that a lot in the past. In terms of architecture, I think the stack that I've described, the starting points, if you're writing a distributed app, I think Akka is pretty hard to look beyond. It's not to say that you can't do it without Akka. You can, of course, but it's been incredibly useful, particularly Akka clustering. I personally have enjoyed Akka clustering a great deal. So before this project, I've played around with Akka, but I've really gone pretty deep on it now, and it works well. It works really, really well for this. Yeah, and we've Akka clustering has been tested incidentally on 2,500 nodes already, so we know how it behaves, at that sort of level. And hopefully 2,500 is going to be enough for most people right now. Thank you. Yeah. Any more questions? You just all want beer now, don't you? You've got to beer o'clock. Okay, well, thanks very much for coming and for making it to the last session.